Hello everyone and very warm welcome to you in today's webinar. I am from Truechip's IP team and going to give you a presentation on NOC. Let's look at the agenda that we are going to cover today. We'll be talking about need for NOC, then we will look at what NOC is. Then we are going to cover advantages of NOC and various use cases of different topologies of NOC that are there. Then we will talk about Truechip's solution for NOC and different flavors of NOC that Truechip provides, which is Crossbar and Mesh. Then we'll be looking at the challenges of NOC and concluded by Truechip's NOC features and deliverables. So let's talk about need for NOC. Being required in chip to support communication between many cores and peripherals, it makes it a key component in SoC. And as we know today, as the size of the chip continues to shrink, the contribution of NOC becomes even more critical. NOC works on single to many, many to single, many to many endpoints for data transfer, and hence creating a need for not only data path for the flow of information, but also incorporate router-like structure to handle complex scenario of sending these transactions across many points. Also for handling issues in SoC, such as wiring complexity, bandwidth bottleneck, scalability issues, by using modular and hierarchical structure, NOC provides a good advantage for the networking. So now let's look at what is NOC. A network on a chip or a network on chip is a network-based communication subsystem on an integrated chip between blocks in a SoC. So these blocks can be any kind. This can be cores, this can be various peripherals. The entire communication subsystem is what actually a NOC is. It is a design approach that treats the component of a system as a node in a network and connects them using communication infrastructures. These infrastructures can be made of routers, switches, links on a chip. So NOC is suitable for application that requires high parallelism, heterogeneity, and reconfigurability, such as multiprocessor system, machine learning, multimedia processing. These days, AI also uses a huge part of NOC. So to connect essentially from different kind of blocks, and not just the connection, but providing a routings as well, is basically what a NOC is. As we can see from the diagram, we can see that there is a router, there's a link, there's a management core, processing element, thermal sensors. So all of these are connected by these links in between. At the same time, these routers will be efficiently managing the transfer of information. So at the same time, parameters like performance, latency, all this can also be managed efficiently. Okay, so now let's look at advantages of NOC. What do we get if we are not connecting them with a formal technique, but then going for a NOC? So scalability. As we know, the number of components are just increasing, right? So to handle that, increasing demand of communication bandwidth. So if the number of components increasing, we should not be choking the bandwidth as well. The quality of service by flexible topology and routing algorithm. So different kind of SoC may have need of different kind of topology altogether, right? So that also is an advantage of a scalability provided by NOC. We'll be looking at it in more details in upcoming slide for topology. So now let's talk about power. So if we talk about NOC, low swing signaling, dynamic voltage and frequency scaling, power gating techniques, all of these are highly helpful in terms of power consumption if we talk about NOC in a SoC. Reliability. Because of using adaptive mechanism and making the design fault tolerant to handle with variation and defects, it becomes more reliable to use in a NOC, in a SoC. Performance, reducing latency and contention, enables parallel concurrent communication. So all of this helps enhance the performance instead of the traditional pipeline architecture. Multi-clock domain. So this NOC, because having a huge network in the entire chip, there can be need of having a synchronous clock domain or asynchronous clock domain. Either of these can be handled by a NOC, by the technique known as clock domain crossing. At the same time, if let's say someone is using unclocked asynchronous logic, that can also be handled very efficiently. Now, after the advantages, let's look at the architecture. NOC architecture basically is modeled on two kind of network. They can be small world network. So what happens in this, most of the nodes are not neighbors to one another, but then they are neighbors to likely to each another. So this, apart from, we can have scale-free network as well, where placement of nodes follows the power law. So they can be scattered also. So these we can understand, like in a SoC, if there are chips placed at very different locations, that also can be taken care of NOC. Whereas in a chip, whereas there is huge density of peripherals or nodes towards each other, that can also be handled by NOC. So it, what we understand, it does not limit to do so with the limit of number, length, area, and power consumption of interconnection of wires and point-to-point connections. Designer can opt for either of the model and hence chooses the topology that caters the need of the SoC is the more efficient way. So now what we're talking about is that we understood, okay, the need of NOC is there because there's huge complexity of catering the need of data transfer, that too efficiently, but different kind of NOC may require different kind of solution, right? So now we'll be looking at what different kind of NOC we can have depending on that. So that can be covered in the topology. NOC topology is highly versatile and totally dependent on the design requirement or the budget of the SoC. Over here, budget of the SoC, I mean, what is the latency budget, what is the performance budget, what is the area budget. Some of the commonly used NOC topologies are star, crossbar, ring, 2D mesh, bus. More complex structures are including 3D cubes and 4D hypercubes, and also these like are used but are rarely employed. For some NOC where these are not perfect fit, right? Still we can have like a combination of different kind of structure. So let's say a crossbar and mesh can be joined together, or maybe a tree with different hierarchy of branches can be there. So the advantage of NOC that we can see over here, it can fit any and every situation. You just have to tweak the architecture like that. Okay. Now let's talk about Truechip Solutions NOC IP. So NOC IP provided by Truechip is compliant to the latest bus protocol like G, AXI, APB, AHB, and tiling. And being compliant with the latest bus protocol, it also supports all the legacy versions. NOC IP comes basically in 4 flavors, which is crossbar and cache coherent crossbar, mesh and cache coherent mesh. These are highly adaptable and configurable, and that can easily configure the need of any SoC. So you can plug in and configure these flavors of NOC also in whatever version that is required by the SoC. TrueIGUI by Truechip makes it very much efficient for the user to generate and customize NOC as required. As we're talking about, the SoC can house a huge number of nodes, peripherals, or cores. It becomes kind of tedious task to create all of them connections individually and configure them. So what this tool does, it cuts down a lot of man hours, at the same time providing you a very good user view about how the architecture is going to be and where the connections are. Okay. Now let's look at Truechip solutions for NOC IP. Let's talk about more about it. So what is different, what is like unique about Truechip's IP is that it is highly flexible. Code may be running with different data widths for different type of maybe AMBA protocols on different versions. Still, they can talk to each other very efficiently and communicate with each other without having a need of any extra or external converter or glue logic added. So let's say if you have a AXI port communicating with a HB port, so you do not need to have any kind of converter over here. The communication is still going to be done in a very efficient manner. NOC in Truechip comes with various modes for user to select, which is best fit for their user requirements. So these modes can be power efficient mode, these can be performance efficient mode. So what it does, it automatically tweaks the entire Truechip NOC and it helps user to find what is the best fit for their SoC and run. Synchronization issue with NOC, it is not a problem with Truechip IP as it comes with customizable addition of register slice and that too option choosing of what depth these additions are required. If user faces a deadlock, it is guaranteed to have zero deadlock in Truechip's NOC as we use node duplication and adaptive routing algorithm to enable this NOC deadlock avoidance, we can have this backdoor for critical node, or user can customize it as per their SOC need. So now let's talk about use cases. Let's talk about Crossbar first. So Crossbar essentially is a NOC-like structure in which M cross N architecture would be there. There would be N number of master communicating to N number of slaves, and there is no limit to this amount as such. A Crossbar would be really useful in a case where high performance computing would be required, such as supercomputers, data centers, and which require low latency and high throughput. High-end GPUs and other high-speed processing unit that requires high bandwidth and low latency communication are the one which actually employs crossbar architecture. Star topology. So essentially, if we see star topology, it is like a center would be communicating to all the neighboring nodes. So these would be really useful in small embedded systems. Consumer electronics who have a low bandwidth requirement or low number of processing elements, they can actually employ this topology. System with low scalability requirements and low fault tolerance also are the one who basically use star topology. Tree topology. So in tree topology, what we can see is that there'll be essentially a one point communicating to many points, and then they can further communicate to multiple points. As we can see from this architecture, it does not need to be a single point of contact, but essentially the idea is that the information keeps on flowing in terms of branches to the more we move towards the hierarchy. So being said that, hierarchical system includes system that has initiated target structure or a central processing or multiple peripheral devices. So cluster system would be a system in which this architecture would be highly useful. It requires very few wires and switches. These can be more energy efficient, as data routing would not be a problem over here because the direction is actually fixed. So let's talk about mesh. So a system which requires many modes and moderate communication requirement, those are the one who goes by the mesh topology. So for consumer electronics or small embedded systems, mesh would really be a good choice if we compare to a crossbar, because it is more cost efficient and at the same time it is easier to implement than a crossbar. It needs fewer wire and fewer switches, and hence if limitation of resource is a issue, in that case you can go for mesh. Multi-core processor where each core is connected to nearest neighbor for inter-core communication. In that case also mesh is the choice. Mesh topology can be beneficial for a large scale data center. Okay, so scalability and fault tolerance, if these are essential, one should go for mesh. These are also suitable for AI applications. Torus, let's look at this also. So Torus is a system where 2D and 3D grid structures are there. So for GPUs, for VPUs, these are the correct kind of architecture one should go for. For large scale system where high fault tolerance requirement is there, such as data centers and cloud computing system, Torus architecture would be it. So it is an alternative topology for AI applications as well. Earlier we were talking about mesh. Compared to those, Torus gives high availability and reliability. They can also provide scalability, and it is easier to expand the nodes just by adding the nodes. So now let's talk about a use case of ring. So ring, if we see what happens, the number of nodes, if they are limited, right, such as embedded network or sensor networks, in that particular case, one could go for ring topology. It is a system in which, let's say, if a message has to go in a particular fashion, in a particular order, in that case, ring topology would be relayed. Okay, so that concludes our topology section. Now let's look at NOC IP structure that Truechip provides. So as you can see, crossbar and mesh are the one that are mostly used and can solve huge throughput and latency budget requirement. Apart from that, if scalability also is required in this case, one can go for crossbar and mesh. The number of masters over here, which is n, and number of slaves which are here, in which is m. Either of these does not have any limitations on the number of master and slave you want to employ. At the same time, you can have different kind of master talking to different kind of slaves. In mesh, again, you can have n cross m kind of mesh architecture in which these nodes can further be configured as a master or a slave. You can have as many number of masters or slave as required. And the same rule applies over here also. Any kind of port can be configured over here. You can have AMBA, you can have tile link, you can have different bit talking to each other, and those are also going to go efficiently. Apart from different type of nodes, you can also have very adaptive algorithm of routing that is being used in mesh. Okay, and talking about routing in Crossbar, also you can have a selective number of arbitrations that are used over here, which can again be customized as per the SOC needs. Okay, so now let's look at the IP features that Truechip provides. So for network topology, we use acyclic agent graph, which enables us to support both layered and parallel NOC. The ports are highly configurable. You can configure them as master or support and or slave. Plus, you can configure each of them individually. For protocol support, AMBA-CHI, AXI, HB, AXI stream, tiling, all of these are supported. Their latest version as well as the legacy versions. For memory map, configure memory map for different access types of memory regions are possible. We do have multiple protocol support as already discussed. Different data width, yes, you can have the protocol specify different data widths for any of the protocol support that we were talking. Early response is possible. You have to enable early response in Truechip's NOC IP. Modifying transfers is very much capable. Truechip's IP is very much capable of modifying transfers. If merging of transfers is required, that is possible. If breaking of transfers is required, that is also possible. Different nodes over here that we're talking can operate at different frequencies. They can in phase, they can be out of phase, and that too individually for master and slave. We do provide clock gating mechanism as well. For quality of service, priority, and programmable register. These are the two kind of features that we provide. User can choose either of them as desired. So for lower latency, what happens is the request and response that has to propagate through NOC. The routing is done as such, it will take the minimum latency required. For Indianness, Truechip IP provide both little and high Indianness. Address conversion, so we do support physical address conversion through NOC. User can tell us the kind of physical address mapping is required, and the NOC is automatically going to take care of it. Register slicing for asynchronous interface is available. NOC master and slave interface can be separated from the internal matrix. So Flaton is also available in Truechip's IP. We do provide configurable outstanding for read and write independently. So there is no choking of total OT. We do provide purport reset control, operation mode. So we have placement friendly mode, we have low congestion mode, we have dynamic low power consumption, latency friendly. So what it does, it automatically tweaks the NOC IP so as it will operate in the mode as chosen. No duplication. So what will happen in case of fault detection, a backup node will be enabled automatically in the data path. So there'll be no blockage of any data transfer. So now look at some cache features. So cache lines are available and they are configurable, both cache lines and cache sizes. If we talk about the states, all the cache states are supported, which is UC, UD, SCSD, UCE, and UDP. We do support all kind of nodes. We support full coherent nodes, non-coherent node, and miscellaneous nodes as well. Support for direct cache transfer and direct memory transfer is also supported in NOC IP. We can have cacheable transfer, we can have snoopable transfer, snoop filter can be enabled and disabled if required. And for cache, we do maintain hardware coherency between connected ports. So that's all about the NOC IP that Truechip provides. Okay. So being said that, let's look at the challenges of NOC. So what is the challenges of NOC that we face till date? So designing and verifying the network architecture, protocol, and the interface, as well as integrating them in the network with the component of the systems, right? It requires high level of abstraction and automation. Because see, every NOC is different, right? Their need will be different. So designing first as per their need and again verifying it becomes a task. Testing the network functionality, performance, and correctness, and debugging them as well, diagnosing the faults and correcting them. It is a biggest challenge of the NOC that we face today. Last challenge that we're going to talk about is the NOC introduces some overhead for sure, as it adds to latency, it adds on to area, and it requires power also. So what happens, it adds on to the overall cost of the network infrastructure and management. Now let us look at the TrueChip IPG. How does it actually help us in generating different kind of a NOC? So this is a snippet that we can see over here of the Truechip's TrueChip. So what we can do in IP generation, first we are going to look at the IP configuration, in which we get to choose if it is a NOC type, is a crossbar or a mesh. Once we are done with that selection, we are going to move ahead with choosing the number of master and slave ports. Okay. After which it enables us to configure those ports individually. So this is just a small snippet. We will have a detailed demo about how we go on generating a NOC, right? At the same time, let's look at example of mesh. So what we do in this particular case, again, we'll have to go through the same procedure of choosing the type of NOC we want, then having the port selection. Now, what this Truechip TrueChip does, it automatically selects the nearest maximum size of matrix, and then it's add on to the remaining node, and it also gives us flexibility of choosing where this want. Excuse me. So for port selection, what it does, it asks us for the number of node, and then it chooses the nearest matrix size, giving us with the remaining nodes. It also gives us flexibility of choosing where we want this particular node to be placed at. And once we are done with that, it gives us a architecture, okay, as we can see, with option of hard break and soft break as well. Plus, then we will go on further with configuring ports. So this brings us to the last slide of this webinar, Truechip's NOC IP deliverables. So if one goes with Truechip NOC IP, you'll be getting the NOC matrix, which can be configured in these flavors, crossbar mesh, cache coherent crossbar, and cache coherent mesh. The ports that you'll be getting can be configured in either of the AMBA protocols or tiling protocol with various version support. You'll be getting IP generator and config tool as well, that we have already discussed is very much helpful in generating the IP and configuring. You'll be getting Verilog test bench with basic Verilog test cases. So you can plug in this test bench and run the basic transactions. You'll be getting a CDC constraint file as well, as we have already talked about synchronization, right? So for that, we do give a preloaded CDC file. You will get a detailed analysis report for the IP. It will contain the linting report, synthesis report, CDC code, and the code coverage exception file. We do provide simulation script as well, which enables you to run the Verilog test bench, or if you want to run your own test bench, that also is going to work. For the document side, we provide a IP block guide, which have a detailed description of the blocks and the features that Truechip IP has. And the last thing is the IPG guide. It is again the IP generator guide, which enables you to understand how to use this tool efficiently in order to generate the NOC required. So that is all from my end. Thank you so much. If you have any query, please do send us a mail on the mail ID given below. Thank you.